Hello everyone, and welcome to today's webinar. I'm a virtual avatar in Developers Shore. I hope you're all doing well and ready to learn. Before we get started, I just wanted to take a moment to invite you to become a member of the Great Devs. As a member of the Developers Shore community, you'll have access to our job opportunities, activities, and future webinars. You can join us by responding to our invitation email or completing the form on our website. Also, a recording of this webinar will be on our LinkedIn page. Without further ado, let's dive into today's topic. Please give a warm welcome to our speaker.
Welcome to today's webinar, Pulse of Concurrency. So we are going to JavaScript and how does it work? What does asynchronous mean? What does parallel means? And so other fancy stuff. At the beginning of my, learning event loop and how asynchronous work in JavaScript and stuff, I feel like that it's like a spoiled child out there that I always try to keep my distance from. No, I'm a strong and capable man. I must learn it. So that was the time that I decided, yeah, let's do it. So how can I start? Just wander around. How does JavaScript work? How does the core principles of JavaScript is? And all of these things we are going to learn together, right? So let's go. As you know, my name is Mohamad. I'm senior software engineer at ING in Netherlands. I'm here because I'm starving for JavaScript. First of all, does asynchronous, async means parallel? Whenever we are talking about asynchronous, does it really means parallel? Actually, it's not. Why? Because JavaScript is a single-threaded language. Whenever it comes to single-threaded language, it means that there's only one thread going on and everything is dependent on that thread. So it means that if we want to run any JavaScript code, everything goes into that single thread. So whenever we are dealing with one thread, so it means that if JavaScript is busy with something, it can't do anything else. It's not like other languages out there, for instance, C++, C, C#, and Java and stuff, which has multiple threads in order to run, different things. But JavaScript is a single-threaded. It is super important for this type because everything is dependent on that. So keep in mind. So my question is, can JavaScript handle long tasks? Whenever a task is so long, does it mean that it can handle it? Of course it does, because it's a simple JavaScript. It's a simple task which takes 15 minutes. Let JavaScript run that. It doesn't matter. It is dependent on a lot of things like CPU and others. But let me rephrase my question. Can JavaScript handle long waiting tasks? So what does it mean by a long waiting task? So as I mentioned, we have some long tasks. We have a for loop. We have a for-hour list, which might take 10 minutes. Of course, JavaScript does that. But from time to time, we want to do something which is dependent, let's say, a third party. For instance, we want to send a request to a server and grab some data, list of users, for instance. So this one is a long waiting task. So I should wait for something. As soon as the data arrives, I should do something. One of them might be rendering the list. So it is a long waiting task. Or sometimes I should wait for a timer deadline. The timer duration is 10 seconds. So I should wait for 10 seconds and then do something. So all of these are long waiting tasks. For instance, take a look at this code snippet, which we are going to, dig deeper into different layers of this code. I have a function here, function foo. Makes sense. It just returns a hello, a string. Another function, bar, it calls a set timeout and a callback. And the duration is 1000 milliseconds. So it means that after a second, it's going to run this callback, which is returning JS is amazing. So suppose that I run them at line 11 and 12. Line 11, calling foo. Line 12, calling the set timeout. So in this code snippet, one of the long waiting tasks is set timeout. Actually, the only long waiting task is set timeout. So we should wait for 1000 seconds to run a code snippet, this function, this callback. So let's take a look at it from the call stack perspective. So at the beginning, at line 11, the call stack is filled with foo, function foo. It returns something, hello. So okay, fine. So as soon as we run it, there is no function inside, so done. The call stack is empty. We should move to the next line, line 12, running the next function. Next function is bar. So I'm gonna run bar function. As soon as I try to run bar function, it goes inside, right? Inside bar, we are calling another function, which comes on top of the call stack, right? Call stack is last in, first out. So the last one in, first out. So the next function that goes inside the call stack is line 6, set timeout. Set timeout comes on top of bar in the call stack. So JavaScript is supposed to run this function, and this function, where is this function? So it is inside the browser, which we call Web API. It's part of the Web API. It's not part of the JavaScript engine. It's better to say it because something else is taking care of this set timeout. Again, long waiting task. Let's move on. So our call stack is empty right now because we just ran line 6, which was our latest function inside bar. So set timeout function is done, bar is done, call stack supposed to be empty, which is. But the thing is, what happened to the callback? The callback goes to the Web API. Web API, suppose that in Web API, there are hundreds of service out there. One of them is timer service. Timer service is responsible for anything which is time-based. We have two functions which are time-based, for instance, set timeout and set interval, right? So in this case, we have a callback from set timeout. So set timeout is coming to Web API. Web API makes sure that we are going to run this function after a second. But how does it work? The thing is, as soon as the duration passed, Web API push the callback into a queue. As you see, here I mentioned queues, and we have set timeout callback here. So everything goes to queues. So the queues is filled with one item. As you know, call stack is responsible for running some JavaScript code. So far, we haven't, ran the code snippet, the function that we talked about, the anonymous function, which returns JS is amazing. We haven't ran that to call stack. This is the place that event loop comes in play. Grab one item from queue and push it into call stack. So from call stack, we went to the Web API. Web API, 1 millisecond has passed through the timer service. It goes to the queue and then come back to the call stack because 1 second has passed. And so on and so forth, right? So call stack is filled with a function. JavaScript just need to run it. So it's gonna run it. And then a browser render happened. This is a very important thing that happened in this case. So browser render. So it means that as soon as the call stack is empty, a browser render happened. Why? Because there's nothing else at the moment to run. Okay, it is very important because we are getting back to that soon. So let me recap. We have call stack. It had a set timeout. We reached a set timeout. Since it is a set timeout, we need timer service. We need browser API. So it goes to the Web API. Timer service is going to take care of that. It push that one into a queue. As soon as the duration passed, again, it goes to the call stack, and so on and so forth. Suppose that in some cases, I might have a fetch. Fetch is a long waiting task as well. As we talked previously about it, long waiting tasks are things that are dependent on something else which is not in the control of JavaScript in your browser. For instance, here, fetch is heavily dependent on the server and the API that you're going to call, right? So call stack is filled with fetch. Fetch send a request to the web API. Web API network service grab it, run the API call behind the scene, wait for the response. As soon as the response arrives, as you know, for all fetch functions, we have a then, right? The first parameter of then is, resolve. So as soon as the fetch has been resolved, it was successful. 200, for instance. It goes to, it. We have network service here. Again, the callback, the fetch callback goes to another queue. I'm going to get back to that soon because there are differences between these two queues. Nice. Let's move on. So, next question. Can we do anything in parallel based on all the discussion that we just had? Can we do anything in parallel? So, whenever I say anything in parallel, it means two things at the same time. But so far, we understood that JavaScript is a single threaded. But is it possible in JavaScript? Yes, it is possible. Actually, in Node.js, we have worker thread. In browsers, we have web workers, and we have workers in all other environments as well. So the important thing is each worker thread, which are going to help us to do something in parallel, have their own event loop. So it means that these two event loops should contact with each other. So in workers, we have pass some to the original event loop. But anyway, I just want to mention that event loops are, web workers has separated event loops. So this is the part that, based on the knowledge that we gained so far, with some questions, I want you to learn. So you can have your answers, before me, and compare your answers with mine. So because in this way you are going to learn. So this part is learning with questions. So let's start with a simple code snippet. Suppose that I want to append an element to the body and hide it. So line 1, append child element. Line 3, let's make the display none because I want to hide it. I don't want to anybody see that because I want to do some processing. So, but I was wondering, wait a minute, maybe I'm not doing it correctly. Let me hide it first and then append the element. Why? Because somebody might see my element for even 1 millisecond. But is it really the one that somebody might see it? In order to answer that question, I want to get back to our event loop definition. Do you remember the time that I told you set timeout comes out of web API, goes to the queue and pushed into call stack? As soon as call stack is empty, we have a browser render. So tell me, in this case, since the JavaScript engine is running a code snippet, which is line 1 through 3 in this case, so JavaScript engine is busy. So it means that call stack is busy. So any browser render happened during that time? Not at all. So this is the tricky part. So keep in mind that whenever JavaScript engine is busy, so it's not gonna do any browser render. So you can answer to this question easily. I want to flash an element, make it visible, non-visible. So do you think that this code snippet is going to do that for us? Again, not at all. Because JavaScript engine don't do any kind of rendering from line 3 to 12. Only on line 12, since the display is blocked, JavaScript engine is done. The browser is going to render everything and make the element visible for us. So there is no flash going on here. So let's have some real questions. Start from scratch, the simplest one. What does it like? Of course, here. By the way, answers are here. I'm gonna show them after you guys think that you're ready. So just a log, console log here. Nice, done. So how about this one? I have console log here. I have a set timeout without any duration, by default 0. So it means that it happens after 0 milliseconds. Based on the knowledge that we gained, JavaScript single-threaded, it starts from line 1. Of course, we are going to have here for the first time. And after that, set timeout. Makes sense. So what if I swap the places? First, set timeout, then here. Again, JavaScript is single-threaded. It's going to start from here. Since it is a set timeout, it goes to the Web API. Web API is supposed to wait for 0 milliseconds. So it is 0 milliseconds. So it's going to push it to the queue. But on line 5, is call stack empty? No, it's not empty. We are still running the code. It's true that set timeout has passed, running that function. And the function is in the call stack. But call stack is not empty. I told you, when event loop is going to pick something and push it to the call stack, as soon as when does it? As soon as the call stack is empty. So line 5, it's gonna run line 5, console log here. But this call stack hasn't been ran. So it means that the output would be here and then timeout. The previous one here was here timeout as well. So it means that swapping the place is not going to change anything. Why? Because the thing that we just talked about, going to the Web API, passing the duration, going to the queue and pushing into the call stack happens whenever the call stack is empty. So it means that if we are running line 5, 1 through 5, it's not gonna take a look at line 2. Let's move on. Let's make it a little bit advanced. We have set timeout, we have console log here, and then a promise. As you know, promise.resolve is a function that resolve a function immediately. So it means that the resolve is there. The promise had been resolved at line 7. So let's think about it. We have timeout, we have here, and we have promise. Which one comes first? Again, single-threaded. It starts from line 1, set timeout goes to the Web API. So it's not going to run this callback function immediately. Then line 5, so here would be logged. Then we reach a promise.resolve. Then again, promise.resolve, you can replace it with any fetch. We can replace it with a fetch function. Why I'm telling you that we can replace it with a fetch function? Because suppose that it is a fetch function called API, blah, blah, blah. But in this case, since fetch functions, they had a lot of overhead, like making the HTTP request and the stuff. For sure, it's slower. But in this case, we just resolved it immediately. So we have a promise callback in this case as well. But which one supposed to run after here, timeout or promise? The answer is promise. Why? If you remember the diagram that I showed you previously, I didn't, randomly put 2 queues here. They have meanings. And I mentioned just queues. They have 2 queues, the first queue and the second queue, and they have their own names. And they have their own priority as well. So let me tell you what are the priorities. As you might guess, promise comes first. Why it happened? Because you can guess that the priority of promise was higher. Although promise and timeout in this case, this one is 0 millisecond and this one has been resolved at line 7. Both of them resolved at the same time. But since priority matters in this case, and the priority of promises are higher than timeouts, it comes first. So here, promise, timeout. Let me recap it for you. We have a set timeout. Set timeout is a web API call, so it goes to the web API. Timer service takes care of that. It goes to the task queue. Name of the queue is task queue. And it's supposed to go to the call stack, right? But since both of them has been resolved at the same time, timer service send everything to task queue, but network service, since it is a fetch and promise, since fetch returns a promise, it goes to the micro task queue. And priority of micro task queue is higher than tasks. So what does it mean? It means that whenever we want to push these two callbacks into the call stack, which one comes first? Micro task. So because of that, micro task and then task. So if you get back to the previous question, now we can answer it better. Line 5, because this is single threaded, it starts running from top to bottom. Both of them has been resolved, timeout and promise. Which one's supposed to come first? Promise. So here, promise, timeout, not here, timeout, promise. So promise priority is higher. Why? Because it goes to micro task queue. Nice. So let's make it a little bit advanced. It's same code snippet, but the difference is instead of using promise.resolve, here I'm using new promise and a callback. New promise, actually the constructor of promise is out there for you guys if you want to have a custom-made promise. So I want to have a custom-made promise and resolve it here instantly. So tell me, since inside the body of promise, I'm logging promise, which one comes first? Our previous answer was here, then promise, then timeout. So what about body? Where does it land? If I tell you a tricky, tip about promises, I'm sure that you can answer it so easily. And what is the trick? What is the tip? The tip is, the callback that you pass to the promise, it doesn't mean that it's going to run it in another, worker thread, another thread or something else out there. No, you're creating a promise. So it means that JavaScript is supposed to run that callback immediately. So new promise, a callback, right? So it means that on line 7, which is creating a new promise, the callback function that you pass to the promise callback would run immediately and resolved immediately, because without any delay on line 9, we are resolving the promise. So it means that the answer would be here, body promise timeout, right? So about the priorities, we know, right? So here and body are gonna run in one event loop cycle because, new promise, a callback, it's gonna run the function immediately. Maybe I can show you simple code snippet about that as well. Suppose that we have a function promise to, we have a callback, right? And I'm gonna run the callback immediately. So it means that if I run promise to and pass an anonymous function to that, log here, okay? So if I put a log here as well, and this one body again. So what does it log? Line 5, console log here. So first one here comes, and then it tries to create the promise to accepts a callback we are running the callback inside the promise2 function. So I guess you got the point how promise works. So let's move on. So what if we have a set timeout and promise inside each other? Here I have two promises, two set timeouts. Set timeout at line 1 and 10. You know that priority of microtasks, which are promises, are much higher. So in this case, what do we have? We have two set timeout. So it means that two set timeouts without any duration, 0 milliseconds. So it means that inside our task queue would be two items, timer 1 and timer 2. So since it is a queue, first in, first out, right? Timer 1 is, comes first. So we are going to run set timeouts timer 1 first. So it means that line 2, timer 1 would be logged. And then we are creating a promise and resolving it. So since at this time, queues, just imagine the queues. Two items were in the task queue. One of items is in the call stack and running it. During running that one, another one would be pushed into microtask queue. So now it's a decision time. So running timer 2 or promise callback, which one has higher priority? Promise. So it's gonna run the promise and then timer 2. So the answer would be timer 1, promise, and timer 2. And it totally makes sense because during running a task, a new one came in, a new micro task came in. So in order to run timer 2, we should wait for promise callback to be run. Nice. So it is a code snippet that makes an infinite loop. I guess you can imagine we have a loop function, console log here, promise.resolve, and then running loop again. So it means that it run loop console log here, then here, then here, then here, then here. So it is an infinite loop. I can do the same. Yeah, of course, it's like here, 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 here. I can do the same with a set timeout as well. Again, loop function instead of promise.resolve, set timeout. So what about in this case? Yeah, for sure it's gonna do the same, right? It's gonna have an infinite loop with a console log here, here, here. But there is a difference between the previous infinite loop and this one. And this is this render guy here. Whenever you use a task queue, a render happens between picking tasks. And it makes a lot of differences, between task queue and micro task queue, and a lot of even frameworks out there. A lot of libraries out there are taking advantage of this feature in JavaScript, this feature of event loop, in order to maintain and develop their framework. I'm going to tell you why. So in this one, here, with micro task, with task, it's here render, here render, here render. There is another thing in JavaScript that does in browser, it's better to say that does the same, and it has its own queue and request, and it is a request animation frame. This one does an infinite loop as well. Here render, here render, here render. Why render? I'm going to tell you. So I want to tell you the pick logic. From task item one by one, if additional item comes, it's not going to run it. Just one by one. A request animation frame, pick till completion, till additional ones. But micro task, pick till completion, till making it empty. I guess maybe right now you got the point. Task one by one. Since in the task question, the infinite loop for with the task question, the set timeout, I told you that it's gonna render after each. Why? Because event loop is picking one by one. It picks one, run it, render, picks another one, right? For the request animation frame, it's gonna pick the newly created ones, right? It's gonna pick till it's gonna pick from the queue till the one that you just registered. So it means that if I run one of them, it's gonna do a render. It's gonna do a render and pick the new early added. So let me review on this diagram. Task one by one. So since it is one by one, it does a render. It doesn't block the browser. Request animation frame, pick all of them from the queue till newly added ones. So it means that a render happened if you register a new one. It doesn't block the browser. But microtask, it works in this way that it should empty out the queue. So it works till the end if you register a new one. So let me get back to the promised microtask. See, here we are registering a new one. Since it is trying to empty out the queue, it doesn't stop. None of them stops, but this one, it doesn't even let the browser render and you can see something. I'm gonna show you a demo regarding that. So nice. So let me recap the pick logic. So far, we learned three different things: set timeout, fetch, request animation frame. Set timeout was part of the task queue. Fetch was part of the microtask queue. Any promise would be part of the microtask queue. And request animation frame is part of request animation frame queue. All of them goes to web API. I called request animation frame browser service. It doesn't matter. It's just some services there. We have timer service. We have network service. The priority of microtask queue is higher. So it's gonna pick from microtask queue if there is something there. And also task queue priority is lower. So it's gonna pick from this one. But the differences between microtask queue and task queue is microtask queue tries to empty out the queue. So it's gonna empty out the queue. So if you push something during running a microtask, if you push something into microtask queue, it tries to pick it and run it. So it doesn't let the browser render. But task queue, it is one by one. So it lets the browser render. In terms of the priority, I can't put request animation frame on top of these guys or below. Because of that, I put some dotted line here. Why? Because request animation frame, it runs whenever browser render requested. What does it mean? As you know, in our applications, we have some CSS, we might have some animations and some stuff. Even mouse movements might cause any repainting in the browser. So whenever a browser tries to render something, which is 60 frames per second, if something is inside request animation frame, it's gonna pick it and run it. As I mentioned, it tries to empty out, but not new ones. Microtask queue empty out, task queue one by one. So this is the whole logic of event loop that you can deal with it these days. Let's have a demo. Okay. So what do I have here? I have simple HTML file here. I have three different H1, move 1, move 2, move 3, move A, move B, move C. This one works with task, this one works with microtask, and this one works with request animation frame. I mentioned that move it, so it means that it's gonna move it. Moving it, it moves 1 pixel each millisecond. So if I show you move A, you're gonna get the idea. So I'm just gonna add to the left A plus plus, left B plus plus and stuff. So it means that it moved from left side of the screen to the right side. But the tricky part is here. For the first one, I'm using tasks, loop task. I'm using set timeout. For the second one, move microtask, I'm using promise.resolve to move it to the right, from left to the right. And the last one, I'm using request animation frame. Let's give it a try. So what should I do? Localhost 8080. Yeah. Okay, cool. As you see, I have an animation in the middle as well. Try not to look at it because you might get hypnotized. But anyway, I have move it task, move it micro task, and move it request animation frame. As you remember, since we are picking one by one from tasks, so it means that it let the browser render. Let me click on it. Yeah, it moves. And it doesn't block the browser because you can see everything, right? Let me refresh. Let me use request animation frame. Yeah, this one works as well. So it means that everything is working fine. Refresh again. So task was working because we let the browser render. Request animation frame was working because we let the browser render. Because between picking item, there is a time to render, let the browser render. How about microtask? Let me click on task first to see some movements. 1, 2, 3. See? Everything just freezed. Why? Because of the thing that the pick logic that we talked about. Whenever we are dealing with microtask, since it tries to empty out the queue, our page just got unresponsive because it doesn't let the browser do any kind of rendering, and the main thread is always busy. But it didn't happen for the other ones, right? With the task and microtask. We can wait or exit page. I guess it doesn't give us a chance, so we just need to exit the page. So I guess right now you have a better idea of what does the thing that I told you about emptying out the queue and picking one by one a request animation frame is. But there's another thing that I want you guys to know. Between task and request animation frame, there is a difference that I mentioned earlier. This one is happening whenever there is something in the queue and picking. But request animation frame runs based on the 60 frame per second, right? So it means that if I run this one and this one, as you see, task is going faster because this one runs 60 frame per second, but task, it's not like that, right? Because of that, it's faster. It's 0 millisecond. Actually, it's not 0 millisecond. It's around something like 4 or something. So let's do some kind of calculation for our set timeout. So it was going faster, right? We want to slow it down. So it means it is 1000 milliseconds. So if I divide it by 60, does it help us? This one and this one. See? It was getting there, but it's not quite correct. Because browser, treat it totally different, 60 frame per second and how it should run. In old animation frames, you might see 1000 divided by 60 because they try to do 60 frame per second. Because of that, I was doing that. As you see, it's not the one that we were looking for. So this one and this one, yeah. And if I click on microtask, boom, done. We can't use this tab anyway. As you see, even animations inside this tab has been freezed because it doesn't get a chance. Everything is working with JavaScript, so it must do it. Yeah, again, unresponsiveness. So let me show you another demo. Yeah, I can show you the demo after I told you this. I guess it's better. Yeah. So how about DOM events? As you know, we have DOM events as well. So how does browser and with the help of JavaScript treat with DOM events? In this case, I want to have a click event on an element. So I'm clicking on that one, registering an event listener on that one, and another event listener on the same one. Inside both of these, I'm resolving a promise, then console log one. So guess which one comes first, which console log comes first, which one second, third, and fourth. What if I tell you DOM push click events right after each other to the call stack and run it? So with this hint, can you guess? Let's see the result. Click one, promise one, click two, promise two. You might guess click one, click two, promise one, promise two, but no, it's not like that. So first click one, then promise one, then click two, then promise two. Why? Because of the tip that I mentioned. Browser, as soon as you click on the element, it's gonna push, the first click into call stack to run it. As soon as it's done, it's gonna push the second one, because in JavaScript there are ways to prevent them as well. Nice. Yeah. So let me show you a demo of it. Okay, so what do we have here? Okay, we have click me here, right? So click me is here, the button that I told you. The click me has event listener click and the second event listener click. So let me move this on top to make sure that we are fitting the one that I just showed you. Fine. Even I swap them, as since it's all about priority, it doesn't matter. Let's switch it like this. So let me open console, zoom in a little bit, refresh, click on this guy, click one, promise, click two, as we described, right? Even I can put a second promise here as well to see the result. Click one, promise one, click two, promise two. So yeah, it's gonna work. So what if, let me remove the second one because I want you to compare, promise, task and microtask in this case as well. So let me replace it with the set timeout. Refresh. So what is your guess right now? Clicking on the element, I have a set timeout here and click two. Let's do this. Click one, click two, set timeout. Why it's happening? Because the priority of click events are totally like microtasks. They are going to microtask queue. Since the task queue is not empty and the priority is higher, so yeah, set timeout supposed to go last. So I can show you something else as well. In order to show that, I need to open an incognito because I have some extensions. You might have those extensions function calls inside the performance tab, which is just digressing us from the original path. So let me record, click me, and then stop inside the performance tab. So what happens? Where is my click event? Yeah, there we go. It is our click event. Just happened. We have a function call. Zoom in a little bit. Run microtask. As you see, click event, microtask, and then the other click event. So, and then a pre-render happening here to do some rendering, and here is the actual rendering, recalculating styles and stuff. So as you see, microtask came in between. So let me replace it with a set timeout, refresh, clear, record, click on me, stop. Let's see performance tab. There we go. A task is running here, a function call, which is our click. Our first click is happening here. Our second click is happening there. And then I want to show you, I should zoom out a little bit, I guess, to show you. Yeah, there we go. Here is the update counters, and then set timeout is happening here, and this is the function call. This is the set timeout function call, which is here. Yeah, so let's take a look at console log. Click 1, click 2, and also let's zoom in a little bit more because I want to show you the install timer. Yeah, here it is. See, install timer is happening here inside the first click function and then the second click function. Yeah, that's it. Okay, so that was the point about event loop and other stuff whenever it comes to DOM events. So click 1, promise 1, click 2, promise 2. So there's another tricky one. What if we manually do the body.click? It's going to change everything, to be honest, long story short, because whenever you run click function, it push both of these click functions, not one by one, to the queue. So because of that, click 1, click 2, promise 1, and promise 2. So some bonus tip, and we are done. So first one, hopefully there is a function in JavaScript recently introduced. No, not quite recently, but it is stable and available in all browsers. The function is queue_microtask instead of doing promise.resolve and blah blah blah. So you use queue_microtask in order to queue a microtask for yourself. So tell me, since you know everything right now, queue_microtask on line 1 and promise.resolve on line 5. Which one comes first? Queue_microtask, because both of them are microtask. There's no priority at the moment. First in, first out. The first one came in, queue_microtask. The next one is promise. And also, in Node.js environment, there is another one, next tick, process.next tick. It has its own queue, and we call it nanotask queue, and the priority is higher. So as you see on line 5, we are running a nanotask, queuing a nanotask, and we have queue_microtask here. So by the way, if you run this one, you should run this function inside a node environment. So we have nanotask and microtask. Which one comes first? Nanotask, because nanotask priority is higher than microtask. It doesn't exist in browser, but by the way, next process.next tick. So we know everything. We know everything. By the way, if you haven't seen Ted Lasso series, I highly recommend you. One of a kind. Resources. If you want to learn more about event loop, the one that I really inspired from and I learned a lot, Jake Archibald on the web browser's event loop. The YouTube link is there. If you want to get more advanced about that, scheduling task, HTTP 203 series from Google, you can give it a watch. And also I have a talk about mixing event loop and React together, and how does use effect use event loop behind the scene. Because as I mentioned previously, most of the frameworks out there are using event loop tricks, the one that we just did, in order to handle rendering, stop rendering, and stuff. So we can take a look at my talk. I present it at the Advanced React conference in London, so you can give it a watch. How not to use effect. And also, if you want to learn about Node.js event loop, timers, process next tick, yeah, if you search even Node.js event loop, you're gonna find it. And the whole thing that we just talked about, it's based on the processing model of the JavaScript specification. This processing model is event loop that we just talked about. If you want to learn the procedural work of event loop, even before implementing it inside a browser, this is how it works. It talks about task queue, micro task queue, and other stuff, not in a coding way, because it's just a specification of JavaScript. So it means that the browser has already implemented this for us. It's better not to say browsers, because who's running JavaScript? The browser JavaScript engine is running JavaScript. So it means that the browser is just using its own JavaScript engine. So what else? What else do we need? Yeah, and that's it. Thanks. If you have any questions, you can reach me on LinkedIn and on Twitter. My handle everywhere, almost everywhere, is Shiralizadeh. My last name, hard to pronounce. It is what it is. And mohamad.shir@gmail.com. Thanks.
Our webinar has come to an end. I'd like to extend a big thank you to everyone for participating, and a special thank you to the speaker for a captivating topic. It was a pleasure having you all here today. Have a great rest of your day.